Hello friends, I hope that you are good, well and fine. In today's session, we will be continuing our solutions of NCERT Miscellaneous Exercise Chapter 6 Applications of Derivative. So far we have seen 1 to 6 problem. Now we will be trying to see the remaining problems. Okay, so let's see. The seventh problem. Seventh problem says the sum of the perimeter of a circle and square is k, where k is some constant. Prove that the sum of their areas is least when the side of a square is double the radius of the circle. Let's see. So let r be the radius of a circle and a be the side of the square, then 2 pi r plus 4a is equals to k, where k is constant. This means a will be this value. Now what the sum of areas of the circle and the square, take it as a is given by a is equals to pi r square plus a square, which is equals to pi r square plus a value. We are substituting this k minus 2 pi r by 4. This means a square will be this. Now dA by dr will be what? The 2 pi r plus this thing. What? This is what your 2 multiply with k minus 2 pi r divided by 16 multiply with minus 2 pi. Okay, this, and from here you can see that this 2 becomes 4, and 4 will cancel this as 4 times, as you can see, and this minus will change this sign. You will get the minus here. Okay, now put it equals to 0. What you will get? The critical point. So critical point you will be getting as r is equals to k by 2 in denominator 2 multiply with 4 plus pi. Now find the derivative, second derivative. So second derivative you will get this, and this is already a positive quantity. This means what? This means putting r is equals to the critical point. This means you will have the positive second derivative. Using the second derivative test, you can say that you will have your minima at where r is equals to this. Okay, at where r is equals to this. So your minimum value will be at r is equals to this. This means what? This means now what you have to do is very simple. Now find the value for a. Your value for a will be 2r. As you can see, double the radius of the circle. Okay, I hope it is clear to you. Okay, now let us move next. Now, okay, eighth problem. Now eighth says a window is in the form of a rectangle surmounted by a circular opening. The total perimeter of the window is 10 meters. Find the dimension of the window to admit maximum light through the whole opening. Okay, now what? Now this means, let us see quickly, that let x and y be the length and the breadth of the rectangular window. Radius of the semicircle opening is equals to x by 2. The diagram shows the everything. Okay, as you can see, now it is given that the perimeter of the window is 10 meter. This means x plus 2y plus pi x by 2 is equals to 10. This means x multiply with 1 plus pi by 2 multiply plus 2y is equals to 10. This means y is equals to 5 minus x multiply with pi by 2. Okay, this has your expression. Clear? Okay, now what? I hope that this is clear to you. What we can get from here, as you can see, you will be 2 times 5 minus x by 5. Okay, now 1 plus pi by 2. You will get this as your expression. We did nothing. Okay, just this. Now area will be what? Area will be the square, the rectangle part area plus the semicircle part area. Okay, half of pi r square. Okay, now putting the values, what you will get? So you will have, as you can see, what you will have? You will have x 5 minus x. Okay, sorry, it will be 2, not 5, sorry, it will be 2. Okay, so as you can see 2 is divided, so 2. Clear? Okay, now as you can see what you will have, so here it not be pi, just half. Okay, please do the respective corrections. Okay, you will get 5x minus x square multiply with half plus pi by 4 plus pi by 8 x square. Now what you will have, okay, let's see. So this means let me just once again verify the calculation. So let me do it. So here it will be just 5 minus x half plus pi by 4. Okay, now plus pi by 8 x square. Okay, pi by 8 x square. Okay, so far so good. Now simplify this and this. Okay, so here it must be pi somewhere, so pi, this is correct. Now remove this pi. Okay, this is extra pi, not okay. This means what? I hope it is clear to you. Now derivate it with respect to x. What you will get, this will be 5, this will be pi by 4 multiply with x, and this will be what? Just 2x, and the everything remains as it is, as you can see. Now put it equals to 0 to find the critical points. So from here what you can get is 5 minus x multiply with 1 plus what, after multiplying inside 2, okay, inside you will have 1 plus pi by 2. Okay, this means this as your expression. Put it equals to 0, then you will have your x critical points. Okay, now also at this stage we will find what the second order derivatives, which means minus of 1 plus pi by 2 plus pi by 4, the constant term, it is negative constant term, it is already negative. Okay, this means you will have maxima, okay, at the critical point, and the critical point will be what? 5 minus x multiplied with 1 plus pi by 2 plus pi by 4, x is equals to 0. This means 5 minus x minus pi by 2 multiply. Okay, so it will be what? Minus of pi by 2x and plus of pi by 4x. This means taking 4, it will be pi x minus 2 pi x. This will be minus pi x by 4. So minus x pi by 4. Okay, this will be your expression after simplifying. Now values will be what? X will be 5 divided by 1 plus pi by 4. Okay, 5 divided by 1 plus pi by 4, and simplified version will be 20 divided by pi plus 4. So this means at this critical point you will have your maximum. So using the second derivative test, we can easily say that at this point you will have your maximum. Okay, so x will be this, and if you want to know the y, so put the y value, sorry, substitute your x value in expression. In the expression you will get y as 10 divided by pi plus 4. Okay, I hope it is clear to you this. Okay, okay, clear. Okay, let us move next. Please do these the corrections. Let us move next. Now ninth, so a point on the hypotenuse of the triangle is at distance a and b from the sides of the triangle. Show that the minimum length of the hypotenuse is equals to this thing. Okay, so we want minimum thing. So in order to minimize and maximize the thing, so we need to what? The second derivative test. So first of all we have to find the expression and then derivate it for first time and derivate it second time, and from the first time you will get your critical points and all of that. Okay, now ABC is our right angle triangle. AB is take it equals to x, BC take it equals to y. Okay, Now as you can see, AB your perpendicular is x, BC your base is y. Now P be any point on the hypotenuse of the triangle such that P is at distance of A and B from the sides AB and BC respectively. Okay. Now as you can see, now take angle C. So this is what your angle C. Take this angle BAC or ACB, this angle as equals to theta, as this is parallel as this line. Okay, is parallel, this means this angle will also be theta. Okay, now what? Now AC using the Pythagoras, what you know, we know this is as your x, this is your y, this means square of this and square of this, sum it, find the root, you will have your hypotenuse length. So AC will be root of x square plus y square. Okay, so far so good. Now and PC if you want to know, PC is what? Your hypotenuse. Okay, or in other words, if you want to say that what okay, in terms of this, so ratio of this PC and perpendicular, you know what it is, so okay, perpendicular. Okay, so you know that hypotenuse by perpendicular, it is cosec theta. So this is what already written over here. After cross multiplication, PC will be B cosec theta. Okay, we just use the simple ratio format. Now AP will be what? As you can see, AP, where is AP? AP will be in terms of A, what? This is your base. So AP will be what? Sec theta. Sec theta is just nothing but hypotenuse by base. Okay, so as you can see, AP will be A sec theta. Now what? Now you know that AC is equals to AP plus PC. So sum them, you will have B cosec theta plus A sec theta. Okay, now find the derivative with respect to theta. What you will have? Cosec derivative will be minus of cosec theta cot theta, and sec derivative will be sec theta tan theta, as you can see. Now put it equals to 0. What you will have is critical points. Okay, so first of all, let us just do what? Simplify them. Okay, what you will have, let's see. So you will have A sine cube theta is equals to B cos cube theta. This means what you will have, tan. If you want to simplify at this stage, you will have tan q theta is equals to B by A. In other words, tan theta is equals to cube root of B by A. That's it, as it is already written over here. Now from here, what you can say is that sine theta. Okay, sine theta will be what? Sine theta is just nothing. Use the trigonometric thing, okay, or the triangle formula if you want to. Okay, so what? That tan theta is what? Ratio of what? Perpendicular by base. Yes. Okay, so perpendicular is cube root of B and cube root of base is cube root of A. Now sine theta is what? Perpendicular by hypotenuse. Hypotenuse is what? Square of this plus square of this and root. Okay, clear? I hope it is clear to you. So hypotenuse is this. Now sine theta is equals to perpendicular by hypotenuse, as you can see. Now cos theta is base by hypotenuse, as you can see. So it is clearly shown. If you now find the second derivative, so second derivative will be always negative. Okay, just try to find. Okay, I'm leaving this thing for you. You must get this, the negative. This means when we are only talking about when theta tan theta is cube root of B by A. Okay, on the critical point. Okay, at the critical point. Now therefore, we're using the second derivative test. We know if a second order derivative at critical point is negative, this means we will be having some maxima. Okay, so maximum occur when tan theta is equals to cube root of B by A. Okay, this means now putting tan theta as B by A cube root, this means you will get your maximum Okay, hypotenuse. Okay, so this will be AC will be what? A square power cube root of A square plus cube root of B square and whole cube and again whole root. Okay, this is what written over here. So the maximum length of the hypotenuse will be this. Okay, I hope it is clear to you. Now let us move to the 10th problem. Now find the points at which the function f given by this expression has local maxima, minima and point of inflection. So what we have to do is just find the first order derivative first. Okay, clear, and put it equals to 0 and then try to see that at where our first order derivatives expression change its sign from negative to positive or positive to negative, then we can say that this is minima, this is maxima, or this is neither minima neither maxima, means inflection point. So let's see quickly. So first order derivative will be, we are using just the product rule. So by using the product rule, this second thing remains untouched. We have to do the derivative of the first, which will be just 4x minus 2 whole cube and plus, now this derivative will be 3x plus 1 whole square multiply with this thing. You will have this. Now take things common, x minus 2 whole power q and x plus 1 whole power square will be common. You will left with 4 multiply with x plus 1 plus 3 multiply with x minus 2. Now your simplified version will be this. Now critical points will be what? 2 minus 1 and 2 by 7. As you can see, 2 minus 1 and 2 by 7, these. Now check for the where you are having. So if you see this point, so if you are approaching this point from the left and from the right, then what sign or what is the effect on the f prime x? Okay, so okay, let's see. As you can see, if you are very close to 2 by 7 and to the left, we are saying from the left hand side. Okay, left hand side, this means what? If you are very close to left hand side of this means what? This will be your positive. Okay, this will be your positive. What about this? This will be your negative. Okay, this will be your negative. What about this? This will be what? If you are very close to this means this will be what? Your negative also. Okay, clear? I hope it is clear to you. Okay, so what I am saying, so first of all let me just visualize you. So this is your minus 1, at this point is your what? 2 by 7, some 0 point something, and this is what? Your 0.2. If you are in somewhere here, this means this will be as negative. As you can easily see, this will be positive, so negative multiply positive will give you negative. Okay, now what about this? This is 7x minus 2. This is 7x minus 2. This means what? This is just nothing but positive thing. This gives you a positive, na? Yes, sorry, the negative thing. Okay, so what it means is that, okay, so negative will give you positive. So that's why if you move towards 2 by 7 from the left hand side, you will have f prime what? Positive. And if you are from a right hand side, you can easily see what happened. Then it will be positive. It is also positive, but it will be negative. This means the negative thing. So you will have negative. So positive to negative, the sign is positive to negative. This means you will have maxima. You will have local maxima at 2 by 7. Clear? Okay. Now what about minus 1? Let's check for 2. Okay. If you move from left to right towards 2, this means this will be your negative. Okay, this will be your negative. All are positive, so this means negative. Okay, as you can see. And if you move from right to left towards 2, Okay, this will be positive, this will be positive, this will be positive. Every term is positive. This means positive. So this means negative to positive. You are going negative to positive means minimum. Okay, you will have minimum, local minima at 2. Now what about minus 1? As you can see, if you move what from the left hand side towards minus 1, then this will be negative. Yes, and what this is also going to be negative. This means positive. You will have positive. So okay, you will have positive. Now what about from right hand side? So this will be also negative, this will be also negative, so say positive. So as the value of x varies through minus 1, f prime x does not change its sign, as you just saw, as f prime x does not change its sign. So this means inflection point. So x is equals to minus 1, okay, is my inflection point. Clear? Okay, I hope it is clear to you. Let us move next. 11th problem. So find the absolute maximum value and values of the function given by this. So x, where x belongs to the closed interval 0 to pi. So first of all, we have to find the critical points and also include 0 and pi values and find the function value at these points. So you will have, let's see quickly. So f prime x will be 2 cos x minus sin x plus cos x. This means put it equals to 0. This will be what? Cos x, take cos x common, you will have 2 sin x minus 1. This means either cos x is equals to 0 or sin x is equals to half, and we know sin x is half when x is what? Pi by 6, and cos x is 0 when pi by 2. Okay, this will happen. Now what? Now critical points will be pi by 6, pi by 2, and also we have to include our endpoints 0 and pi. Now find the points. You will have f of pi by 6 will be 5 pi by 4, f of 0 will be 1, f of pi will be 1, f of pi by 2 will be 1. As you can see, your maximum will be occurring at 5 pi by 6, which will be 5 by 4. Okay, so maximum will be 5 by 4 occurring at pi by 6. Okay, and your minimum, absolute minimum will be this value 1 occurring at 0, pi and pi by 2. Clear? Okay. Now 12th problem. Show that the altitude of the right circular cone of maximum value that can be inscribed in a sphere of radius r is 4 r by 3. So let me just show you the answer quickly. So sphere is r, fixed radius of r, and capital R and h be the radius and the height of the cone, okay, as given in this picture. Now the volume we already know, 1 by 3 pi r square h. Okay, as you can see. Now from the right angle triangle BCD, as you can see, BCD, this you will have BC length as root of r square minus capital R square. So you will have this. Now your h, as you can see, your h will be what? Okay, h will be, okay, h is your height of the cone. So far so good. So h, as you can see, h will be r plus root of r square minus r square. Why I am saying that? Because, okay, so h is what? AC. H is what? AC. AC is AB plus BC, and AB is what? R, and BC is root of r square minus r square. So this means r plus root of r square minus capital R square. Now volume will be pi 1 by 3 pi r square h. H we can easily replace by this. So you will have this as your expression. Find the derivative with respect to capital R. You will have this as your expression. Please go through or be careful with these derivative. It is already written over here. Okay, so please verify it. So now what you have to do, now put it equals to 0 to find the what? The critical points. Okay, so find the critical points, put it equals to 0, you will have this. Now what will be your critical points? Also be careful as the equation is too complex to handle, so that's why, okay, so be careful. So you will have your R, capital R square, as this your value, your critical point. Now you will have to find the double derivative, as you want to know maximum and minimum things. So you will see that at your critical point, you will have double derivative negative. This means maximum will occur at this. So okay, I hope it is clear to you. So when R square is equals to 8, R square by 9, the height of the cone will be R plus this. Substitute the capital R square value, you will have your height of the cone as 4R by 3. This is the thing you wanted to show. Okay, now let me just show you the problem number 30. Now let the function be defined on this closed interval such that f prime x is positive for all x open interval a to b. Then prove that f is an increasing function on this interval. So quickly take any two points in the open interval a b. Now c2, c2 we are taking as c1 plus h, where h tends to 0. Okay, now f prime c1 is equals to limit h tends to 0, f c1 plus h minus f of c1 divided by h. This is the definition for what? Derivative. Okay, using the limits. So you will have f of c2 minus f of c1, c2 minus c1. Okay, so far so good. Now what? Now it is given that f prime x is positive. Okay, yes, for every x in this interval, therefore f dash c1 is going to be positive. Okay, so this means this is positive. This means f of c2 is greater than f of c1. F of c2 is greater than f of c1, where c2 is greater than c1. Okay, f of c2 is okay. I hope it is clear to you. Now if for c1 is greater than c2, this means f of c1 is going to be greater than f of c2. So this thing shows that fx is increasing function in this interval. Okay, I hope it is clear to you. Okay, if you want to show that your function is increasing or decreasing, the one basic thing to show is that if you have 2 points in this manner, that this x is less than this point y, then if it is increasing, then their output will be also in the increasing form, which is fx is less than fxy. Okay, this is what we have shown. Now let's see the solution. The remaining problem, how many remaining problems we are having? So just 2. Okay, so now this problem. Okay, so show that the okay, so let me just so problem number 15. Quickly let me just show you the solution, explain the solution for you. Now show that the height of the cylinder of the greatest volume, which can be inscribed in a right circular cone of the height h and semi-vertical angle alpha is 1/3 that of the cone, and the greatest volume of cylinder is 4 by 27 pi h cube 10 square alpha. Now so the given right circular cone of fixed height h and semi-vertical angle a, or you can say alpha, okay, can be drawn as you can say your semi-vertical angle is here alpha. Okay, it is your alpha. Okay, and height is h, as you can see AO is h. Now here a cylinder of radius r and height h is inscribed in the cone. Then this means what? The angle GAO, as you can see, this angle, this semi-vertical angle is equals to alpha. Okay, and OG is what? Small r. OA is what? Your small h. And OE is what? Your capital R. And CE is height of the cylinder, which is capital H. Okay, clear? Okay, we have what? R is equals to S tan alpha. Okay, we just use the ratio thing. Tan alpha will be what? Perpendicular, which is AO. AO is H. By base is OG. OG is what? OG is R. So this is what we used. Okay, clear? Now since triangle AOG, as you can see, triangle AOG is right triangle, and also the similar to CEG, as you can see CEG, yes, this means their corresponding sides ratio will also be the same. Okay, this means AO divided by OG will be same as CE divided by EG. This means small h divided by small r is equals to capital H divided by small r minus capital R. Okay, now capital H will be small h divided by small r multiplied with small r minus capital R. So replacing the small r in form of h and tan alpha, you will have h divided by h tan alpha. H will be cancelled, you only left with 1 by tan alpha multiplied with h tan alpha minus capital R. Now the volume will be pi r square h. You will have what, replace the h as this, replace the capital H as this, you will have this as your expression. Now find the derivative with respect to capital R. You will have this as your expression, put it equals to 0 to find the critical point. You will have capital R as 2h divided by 3 multiplied with tan alpha. Now find the double derivative to find maximum and minimum thing. The double derivative will be 2 pi h minus 6 pi r tan alpha. Now find the double derivative sign at critical point, which is 2 h divided by 3 tan alpha. Okay, you will notice that it will be negative. Negative means the maximum will occur at this critical point. Capital R is equals to 2h by 3 tan alpha. Okay, this means, okay, so your capital R will be this, your capital H will be, just replace the R, you will have h by 3. Okay, clear? Thus the height of the cylinder is 1/3 the height of the cone when the volume of the cylinder is greatest. Now the maximum volume of the cylinder can be obtained by using what? Substitute these value, h by capital H by small h by 3 and capital R by 2 times of small h multiplied tan alpha divided by 3. Just put it and you will get your maximum what volume, and this is the thing you have to show. Yes, as you can see, 4 by 27 pi h cube tan square alpha. Okay, as you can see. Okay, so 4 by 27 pi h cube tan square alpha. Okay, clear? I hope it is clear to you. Now the last problem of this miscellaneous exercise chapter 6. Okay, just quickly let me just show you. A cylindrical tank of radius 10 meter is being filled with wheat at the rate of 314 cubic meter per hour. Then the depth of the wheat is increasing at the rate of what? So let me just show you the answer quickly. Okay, let R be the radius of the cylinder, V be the volume of the cylinder, then pi r square h, the volume for the cylinder. This means pi r is a small r, and okay, r is what, your radius, which is small r, and h is your small h as height, and it is already given that the radius is equals to 10 meter. This means your volume will be, in terms of height, will be 100 pi. As now differentiating with respect to time, we want with respect to time. This means dv by dt is equals to 100 pi dh by dt. This means it, okay, and we are already given that this rate dh by dt, which is 314, this means dv by dt is equals to 314 meter cube per hour. Okay, thus we have 314 is equals to, so dv by dt is equals to this thing, so this means you will have dh by dt is equals to 1. Okay, clear? So we have already we have to find this dh by dt. Sorry, I think I have misinterpreted it. Okay, so what we are given with, this volume rate is already given with respect to time, means dv by dt is already given. We have to find the dh by dt. Okay, so putting it equals to 0, you will get dh by, sorry, putting it equals to 314, what, dv by dt, putting it equals to 314, you will get your dh by dt as equals to 1. So hence the depth of the wheat is increasing at the rate of 1 meter per hour. So answer option 1 will be your correct. Okay, clear? So that's it for this miscellaneous exercise. I hope that you understood it. Okay, so thank you